In this video, we're revisiting graphical representations of data to see what the shape of a graph can tell us about the data it represents. Let's get started. So far, in our studies of statistics, we've analyzed data using statistical values. Today, we're analyzing the shape of a distribution to find out what the shape can tell us. In the pre-video activity, you created 3 histograms for 3 different data sets. If you haven't completed the pre-video activity, pause the video and do that now. Take a look at your 3 histograms. What observations can you make about the shape of their distributions? I notice that histograms A and B each have peaks off to one side of the chart, whereas histogram C has a peak right in the center. Our observations about these histograms describe their shape. The shape of a distribution refers to the visual structure of how the values in a dataset are distributed. It describes characteristics like symmetry, skewness, and the presence or number of peaks. Let's start with symmetry, as that is a concept we know a bit about already. Just like when you studied symmetry in geometric shapes, symmetry in data occurs when we can draw a line on the histogram such that the left and right of that line are mirror images of each other, or very close, as we see in the histogram for dataset C. What statistical value do you think corresponds to the line of symmetry on a histogram? If you said mean, median, or mode, you're right. In unimodal symmetrical distributions, mean, median, and mode will be equal to each other, or very close. Check out the values of mean, median, and mode you calculated for dataset C. Are they equal or close to equal? Yep, the mean for this data was 12.4. The median is 13. And the mode is 14. Take a look at this histogram that shows the exam scores for a senior history class. How would you describe its shape? This histogram is an example of a bimodal symmetric distribution. Since it is bimodal, as evidenced by these 2 peaks, it has 2 modes, or 2 values that occur most frequently. However, just like a unimodal symmetric distribution, the mean and median are at the center and are almost equal. Let's summarize what we know about symmetric distributions. Symmetric distributions are symmetric around the median and mean values, which are equal or close to equal. Symmetric distributions can be unimodal or multimodal, though unimodal is most common. What happens when a distribution is not symmetric? Take a look at histograms A and B from the pre-video activity. Are these histograms symmetric? No, these 2 histograms are not symmetric. We can see that the peaks of these 2 histograms are pulled off to one side of the chart. This is called skew. Skewness is the measure of asymmetry in a distribution. The skewness of a distribution indicates where the data is concentrated and can provide insights into the relationship between the measures of central tendency. We describe the skewness of a distribution using the location of the tail. The tail of a distribution refers to where the data values become less frequent and extend further away from the center. Tails are located at either end of a distribution and show extreme values in the dataset. Consider histogram A in your guided notes. Which side of this histogram has a longer tail? The tail on the right side is longer, so we would classify this histogram as right skewed. Alternatively, look at histogram B. Which side of this histogram has a longer tail? This tail is longer on the left, so naturally we call this histogram left-skewed. The skewness of a graph indicates where the extreme values are in a dataset, either above or below the measures of central tendency. We know from our previous lesson that extreme values, or outliers, can affect the mean and median of a dataset. So let's see what skewness can tell us about how the measures of central tendency compare to one another in an asymmetrical distribution. On histogram A in your guided notes, draw 3 lines where the mean, median, and mode are located. In this right-skewed data, we can see that the mode is the smallest value at 15. It is less than the median, which is 18, and the median is less than the mean at 19. The mean is pulled toward the tail because it's easily influenced by extreme values. This relationship between mean, median, and mode will always be true for right-skewed data. Pause the video, draw a line to represent the mean, median, and mode on histogram B, and describe the relationship of measures of center for left-skewed data. As you might have expected, for left-skewed data, the mean is less than the median, which is less than the mode. Again, this is the result of the extreme values of the left tail pulling the average down. Knowing the shape and skewness of a distribution can help you decide what statistical values might be the best choice for representing the data. But can we only see skewness in a histogram? No! Let's look at one last example in which we can examine skewness of distributions in box and whisker plots. Each of the box plots displays a set of data. Examine each and determine whether the plot shows data that is right-skewed, left-skewed, or symmetrical. Justify your reasoning. Pause the video now. Let's see how you did. In the first box plot, the median is much closer to the third quartile than the first quartile. In other words, the data points on the left side of the box plot are much further away from the median than the values on the right. This indicates a longer tail on the left, making this data left-skewed. The next box plot has a median that is closer to the first quartile, indicating a longer tail on the right because the data values on the right are further away from the median value. This data is right-skewed. Finally, the last box plot showing the height of 14-year-olds has a median that is equidistant from both the first and third quartiles. This indicates the data is symmetrical and the median and mean are approximately equal. Today you learned that the shape of a distribution can give us interesting insights about statistical values of a dataset. A left-skewed distribution has a long tail to the left, which typically means the average is lower than the median and mode. A right-skewed distribution has a long tail to the right, which typically means the average is higher than the median and mode. Finally, a symmetric distribution will typically have equal or close to equal values for all 3 measures of central tendency. When you're finished with your guided notes, continue working on the lesson activities before you attempt the online practice. See you next time!